Chapter 1, Problem Solving. 1.1, Calculating percents. Percent means per 100 or parts per 100. So think it that way, parts per 100. So if you look at example 1.1, if 345 people out of 500 state that they like cheese turtles, what percent is this? So it's 345 out of 500, so it's part of the whole. So you take 345 over 500. Then when we divide that, you get 0.69. Now, the way you change from decimal to percent is simply move the decimal to the right and then put a percent sign. Because what you're doing is really multiply the number by 100 and then divide by 100. Because the percent sign means divide by 100. So when you multiply 100 divide by 100, you're really you're not changing the value of the original number. Then you just change the way it looks. So instead of 0.69, it's 69%. We can see some more example in chapter 1. In example 1.2, where we're changing these whole numbers into percent. So for example, 14, how do you change 14 to percent? We're going to multiply 14 by 100, so become 1400. Then we put a percent sign behind it. So what we did was we take the number, we multiply 100, then divide by 100 again. So we're still really getting 14. But instead of writing 14, now we can write 14 as a percent, which is 1,400%. Same thing with 0.02. So if you multiply the 0.02 by 100, you get 2, and you divide by 100, so write 2%. And 2.35 is the same thing, so 2.35 will become 235%. Okay, now as we mentioned before, percent is part out of the whole, okay, or equivalently part equal to percent times whole. Now here's an application to the problem. Example 1.3. A TV originally priced at $799 is on sale for 30% off. If the sales tax is 9.2%, find the price of the TV reflecting a discount and including a sales tax. So when we want to find out a 30% off or 9.2% off, like the sales tax of a certain item, now the off in mathematics, it means multiply. So the first thing we need to figure out is, what is 30% off? How much is 30% off $799? So we take 30% times $799. Now your calculator don't like percent as much, so we want to change that 30% back to decimal. Now how do we change? Just like before when we do decimal to percent, we multiply. So if you want to go back, you have to divide. So if you take 30 divided by 100, okay, then you get 0.3. 0.3 is 30%. So on the calculator, you want to do 0.3 times $799, you will get $239.70. That's how much money you'll be discounted off. Now 30% off means $239.7 off. Then, well, let's figure out how much the new sale price is. We take the original price $799 minus $239.70. Now the TV is only $559.30. That's the sale price. Now, before we have to leave the store, we have to pay the tax. So the tax is 9.2% of the new price. Again, off means multiply. So we take $559.30 times the 9.2%. Now, again, 9.2% means what? 0.092 on your calculator. All you have to do is take 9.2 divided by 100. So then we take then we multiply the number by 559.3. So the sales tax part of this transaction is $51.46. So together, how much is it going to cost me? So it'll be the sale price of the new sales price of the TV, $559.30, plus the sales tax, $51.46. Then so the total price, including tax, will be $610.76. Example 1.4. So the value of a car dropped from $7,400 to $6,800 over last year. What percent decrease is this? Now, so the way we figure out is a price increase or decrease, we need to figure out the change, the absolute change. Now, what's absolutely change means? It means, okay, the difference basically between, or how much was the discount. All right, so if you subtract, you get a negative number, Okay, we just need to change to positive number. We only want a positive difference. So if you take 7,400 minus 6,800, you'll be fine with $600. But if you take $6,800 minus 7,400, you'll get a negative number. So we want an absolute value of it. So it's 600. So basically, to figure out the percent change, we want the positive value of the difference. Okay, once we know the difference between the two, between $7,400 and $6,800 is $600. All you have to do is take that number, divide by the original value. That's the most important part, the original value. The original value of the car is 7,400. So make sure you use the right number to divide. Once you divide using calculator, you get 0.081, and we change that to percent. So the drop is 8.1%. So 8.1% decrease. Okay, so absolute and a relative change, right? So that's what we just talked about, right? So if you look at a relative change, the formula in the box, it says absolute change, how much you change divided by the starting quality, okay? So same thing here. This is another similar example, okay? So in example 1.5, the U.S. federal debt at the end of 2001 was $5.77 trillion and grew to 6.2 by end of 2002. At the end of 2005, it was $7.91 trillion and grew to be $8.45 trillion by the end of 2006. Now, which year has a larger increase in the federal debt? Now, if you're looking from 2001 to 2002, the debt will do the difference first on top. Okay, then now one of the tricks you can do is take the big number minus small number, so you don't have a small, or you don't end up with a negative number. But if you do, just remember you want the absolute change. So make sure you keep the positive value. Then you divide by the original number. Now original, it's going from 2001 to 2002, so the original debt number is 2001. So you take the difference, divide by the original number 5.77, then you end up with 7.5%. You do the same thing between 2005 and 2006. You take 8.45 minus 7.91, divide by where the original number, divide by where it came from. It came from 2005. So once we do that, we get 6.8%. So to compare the two, 2001 to 2002, we saw a larger increase in the federal debt. Okay, so in example 1.6, it says a politician support increased from 40% to 50%. What's the change? Same thing, from 40% to 50% is 10% change. Now, so the numerator in the fraction is 10%. Now, on the bottom, the denominator, we gone from 40 to 50, so original number is 40, that's why we divided 40% on the bottom. Then you'll find out the answer is 25%. Okay. In chapter 1.2, we're looking at proportions and rates. Okay, a rate is a ratio, which is also known as a fraction, of two quantities, each with a different units. Okay, different unit that is. So for example, we're all familiar with miles per gallon. So if you can drive 388 miles in 26-gallon tank of gas, then the mile per gallon will be, take 338 divided by 26, so it's 13 miles per gallon. Okay, notice the fraction has two different units. Okay, so now proportion. Now proportion is the equation that says two rates equal to each other. Okay, also known, we call this a ratio. Now, so if you so let's do an algebra review real quick. If you have 17 over 3 equal to 85 over x, how do you solve for x? Now we probably still remember cross multiply. So we take 17 times x is 17x, and then 3 times 85 is 255. Then we divide by 17 on both sides, you get x equal to 15. Now, what do we use this for? So in this example, for example, a recipe calls for 2 eggs and 1 cup of flour and 1 cup of milk. How much flour would you need if you use 5 eggs? So we're going to set up what we call a proportion. So we have two rates equal to each other. On the one side is the recipe itself, 2 eggs to 1 cup of flour. Now, if you have 5 eggs, now how many cups of flour do you need? Now, if you look, the way we set up is, if you put the eggs on the top, on the numerator of the fraction, you have to make sure on the other side matches. So eggs to egg, flour to flour. Once you do that, then you can do what we did, like the example before. We do a cross multiply. We solve for x, then x will be 2.5 cups of flour. Okay, same thing here. This is another example. You have the 200 truckloads. Okay, they can hold 3,000 cubic yard of dirt and debris. And how many loads you need if your debris is 40,000 cubic yard? So you say that same thing. In this case, I put loads on top, so load to load, cubic yard to cubic yard. If I do that, when I do cross multiply, I'll get the correct answer. Dimension analysis. Okay, so here's your dimension analysis. So if you look at dimension analysis, it's the process that rewrite quantity in different units so that the quantities are comparable. Okay, so like for example, if I want to change feet, so it's conversion basically. I want to change feet per hour, okay, from 12 miles per hour, okay. So I want to go from mile to feet. So the first thing we need to know is how many feet in a mile. So 1 mile equal to 5,280 feet. Now once I do that, I just have to do what we did before using the same idea of proportion. So we have 12 miles, we have to convert. We know that 1 mile over 5,280 feet is the ratio. Then how much is 12 miles? So we set our miles on top and then feet on the bottom. The unknown feet can be calculated by doing cross multiply. If we do cross multiply, we'll get what we need. Now B, now we're going to go from feet per hour to feet per second. Now we're done with converting mile to feet. Now we want to change the time. So we know that, okay, so right now from part A, which instead of saying 12 miles per hour, we say is 63,360 feet per hour. Now you need to change this. So another thing we can do is we can, using what we know about fractions, to cancel our units. So we know that 1 hour equal to 60 minutes. So to place that rate, 1 hour equal to 60 minutes. If we, how do we know we put hour and we put 1 hour on top and 60 minutes on the bottom? Because we want to cancel all the hour, the units. Okay, and then we learn from fraction where when you want to cancel something in a fraction, one has to be on the numerator and the other one has to be on the denominator. So this way hours will cancel. So then once we do that, we get 60 minutes. But again, we don't want minute, we want second. So then we use another relationship where minute to second. So we know 1 minute equal to 60 seconds, but we try to cancel out a minute. So once we cancel out a minute, then the minute. So if you look at what's being crossed out, the hours gone and minutes gone. The only thing left is on top is feet and on the bottom is second. So once we multiply all this in the calculator, we'll get feet per second. Okay. And last but not least, well, how many feet will the bicycle travel in 50 seconds? Well, now we know is it travels at the rate of 17.6 feet per second. Then we use what we learned before again, using proportion. We want to know how many feet, which is x, divided by 50 seconds. Notice feet equal to feet, second equal to second. This is the proportion. So we want to set something equal to each other. You need to make sure the units are equal to each other on top and on the bottom. But looking back to part B, that's not equal sign. That's, you try to multiply and cancel out the units. So in that case, you actually want the opposite, where you want the unit not desirable to you to be one on top, one on the bottom, so we can cancel each other out. Okay, so we have one more example for this topic. So if 1,000 foot spool of bare 12 gauge copper wire weighs 19.8 pounds, how much will the 18-inch pole, okay, weight? So, well, first of all, we need to change what pound to feet. Okay, so 19 pound to 1,000 feet. Well, we're going to get rid of feet first. We know 1 feet equal to 12 inches. So we're going to multiply, so feet will go away. Then once we do that, we're good in inches. But we also need to change pound to ounces. Then we know 1 pound equal to 16 ounces. So we put 1 pound on the bottom, 16 ounces on the top, because we have the original 19.8 pounds on the top. I need a pound on the bottom to cancel things out. So once I do that, I just multiply what's left on the top. Use the calculator, I get 316.8 ounces, because all the other units are canceled out. And then the bottom is 12,000 inches. When I divide those, I get ounce per inch. Okay, now we want 18 inch of that, so we multiply 18. So the final answer is 0.4752 ounces.